All right, the first topic, derivatives of parametric equations. If a function is defined, we say parametrically, you can differentiate both x of t and y of t. So when you have a function that consists of the two parametric equations, x of t and y of t, with respect to t, obviously, then in order to find the derivative of this function, dy dx, you notice there's no t here. So all you have to do is, you see right here, we have dy. So you need to find the derivative of the y of t. So I can either put y prime, or I can put, I think this would be better, dy dt. You find your derivative of a y of t, and then see this line right here, that means division, divide by the derivative of x of t. So I'm going to put dx dt. And really, if you divide these two fractions, you're going to get dy dx. And that's exactly what I'm looking for, right? So it's very simple. So they give you the two parametric equations. To find the derivative, you just find the y prime, you find x prime, and do y prime over x prime. And that's it. So let me show you a couple of examples. So example 1. And it says that a curve is defined by x of t equals t squared minus 3t, and a y of t equals 5 cosine of t. And they want you to find dy dx. So, just as I said, in order to find dy dx, you're going to find x prime first. Or you can start with y prime, doesn't matter. You get 2t minus 3. Then you find y prime, and you get negative 5 sine of t. And then finally, you're just going to divide y prime, which is 5 sine of t, over x prime, which is 2t minus 3. And that's it. You're done. Example 2. It says a function is defined by x of t equals 5t minus 2, and y of t equals 9 minus t squared. Also, they give you this condition that t has to be between negative 5 and 5. T is your parameter, and it has to be within this interval. Find the equation. The question says, find the equation of any horizontal tangent lines to the curve. So we need to find equation, maybe equations, of any horizontal tangent lines. Sorry, horizontal tangent. Okay, so we know that in order to write that equation, we need to find the slope. Okay, so we're just going to do what I did previously. We're going to find dy dx. Now x prime equals 5, y prime equals negative 2t. Therefore, dy dx equals negative 2t over 5. So that's my derivative. That was my step number 1. Now step number 2, it says horizontal tangent lines. So when it says to horizontal tangent lines, in order for the tangent line to be horizontal, dy dx must be equal to 0, right? Therefore, t equals 0. Where did I get this from? Well, the derivative equals to 0 when negative 2t equals to 0. And that happens when t equals to 0. Now, so you know that when t equals to 0, that's when you get that horizontal tangent. Now we're going to take this 0 and plug it into each parametric equation. So we're going to get x of 0 equals negative 2, and y of 0 equals so that means right here. So that means when t equals to 0, the parameter t equals to 0, the point we consider, it has coordinates negative 2, comma, and 9. Now the equation of that horizontal tangent line will be, since it's horizontal, it has to be y equals, and what's the y value at this point? 9. And that's it. And that's your answer. Problem number 3. A curve is defined by the following equations: x of t equals that, y of t equals that, and the t has to be between 0 and 3, including these endpoints. It says find the equation of the tangent line. Tangent line. It doesn't say anything about horizontal. Tangent line to the curve of when, and they give you the specific value of this parameter when t equals a 1. Okay, so what do? We find the slope first, right? That's how we normally start. So that would be step 1. Find the slope. dy dx equals a y prime over x prime. A y prime, you know what, let's do it separately. So y prime, I'm going to actually, instead of using the quotient rule, I'm just going to do this. So that would be bring down the negative 2, t plus 2, negative 2 minus 1 is negative 3. I can rewrite it as negative 2 over t plus 2 cubed. That's y prime. Now x prime is easy to find. It's just 2t minus 5. Okay, therefore dy dx equals negative 2 over this, but then divided by 2t minus 5, or one fraction, negative 2 over t plus 2 cubed, but times 1 over, so that means this guy moves down. So that's our derivative. Now it says t equals 1. That they give you this condition. All right, so if t equals 1, then dy dx at t equals 1 would be negative 2 over, plug in 1 for t, 27, and I think it's negative 3, and it's going to be positive 2 over 81. Now you understand, in order to find the equation of that tangent line, you still need to follow this point slope form. Now the slope we just found, and it is 2 over 81. Now we need to find these guys, the points. That's easy, because the x of t equation you have, it's t squared minus 5t plus 2. So, but t, they give you this condition that t equals 1. So I'm going to just I'm going to use that given equation, I'm going to copy it, x of t equals t squared minus 5t plus 2. Y of t, it was, I believe, 1 over t plus 2 squared. Now, if t is 1, that's what they give you, then the x-coordinate at 1, when t is 1, the x-coordinate is going to be 1 minus 5 plus 2, which is negative 2. And the y-coordinate, when the parameter t equals to 1, is going to be 1 over 9. So we have our point, negative 2 comma 1 over 9. So finally, our equation is going to look like this. Y minus 1 over 9 equals the slope that we got, 2 over 81, and x minus, but plus, because the x value is negative. And that's it. We're done. Next, I want to talk about something that you already done in physics. Okay, so it says, the motion of a particle is defined parametrically. So then the position is given by x of t, comma y of t. Okay. Now we say that the speed of the particle equals the square root x prime squared plus y prime squared. You have to memorize this formula, or I prefer a better version. dt squared, because you're taking the derivative of x in terms of t squared, plus dy dt squared. And that's how we find the speed of the particle. Now, its acceleration is given by the vector, and I assume you discussed this with your teacher, physics teacher. Acceleration. Vector, well, since the velocity is dx dt, vector of the velocity is, let me write it down, velocity, the first derivative of the position, so it's x prime of t, y prime of t. Then the acceleration vector would be x double prime of t, y double prime of t. So these things are very, very important, and you do need to memorize that. So let me show you a couple of examples. Example 1. It says find the speed and acceleration. Speed and acceleration of the particle whose motion is defined by x is 3t, so you know how your x is changing in terms of t, and the y-coordinate is also described. It's changing at y equals 9t minus 3t squared. We have this rule that describes the y. And also it says t equals 2, so we know that specific a time t equals 2. Now step 1, in order to find the speed, we have to do the square root of x prime squared plus y prime squared, right? So we need to find the derivative of x and y. So let's differentiate. That's step 1. Let's differentiate dx dt. and that gives us just 3. dy dt would be 9 minus 6t. Therefore, when t equals 2, that's what they give us right here, dx dt at t equals 2 is still 3. Notice there's no t here, so no matter what your parameter t is, the derivative of x is always 3. Oops. dy dt when t is 2 equals 9 minus 6 times 2, and that gives us negative 3, I believe. Okay, now let's calculate our speed. So the speed equals the square root x prime squared. So what did we get for x prime? We got 3, but at t equals 2, it's still 3. So you just square your 3 plus y prime. Now, y prime gives us this equation, but we need to square it, but we know what t is. We plugged it in and we got negative 3. So just take negative 3 and square it. So you get the square root of 9 plus 9, which is 18, and that would be, I think, root 3 root 2. So that is your speed. Now the second question, part of this question, it says find the acceleration. To find the acceleration, you do need to find the second derivative. So x double prime of t and y double prime of t. So the first derivative, dx dt, we got 3 if you remember. But when you take the derivative of that, you get 0. Now, the first derivative of y, we got 9 minus 6t. Then you differentiate it again, and you get negative 6. So that means when you write your acceleration, you write it as a vector. So the acceleration vector is, now x double prime was 0 and y double prime gives us negative 6. So that's it, you're done. Example 2, it says a particle moves along the curve y equals 1/2 x squared minus 1/4 ln x. That's given, so the curve is given, the equation. And also it says so that x equals 1/2 t squared when t is greater than 0. Find the speed of the particle when t equals 1. So one more time, they give us just the general equation of this curve. Y equals 1/2 x squared minus 1/4 ln x. They also tell you how this x coordinate is changing over time. So when the parameter is t, we use t for a parameter as a variable. So then x equals 1/2 t squared, or I can put x of t equals 1/2 t squared. Now they give us this condition. It says at time t equals 1, you need to find the speed of this particle at that certain value. Okay, so step 1. We know that the speed equals dx dt squared plus dy dt squared. Dx dt we have, and we can find, we can find dx dt and then square it. So that's what we have here. That's easy. We'll find the derivative of that and we'll be done. But done with dx dt. But what about this guy right here? We just have a y equals 1/2 x squared minus 1/4 ln x, and that's the equation written in terms of x. But we use, in this formula, we use dy dt squared. So our y has to be written as a parametric equation in terms of t. So what do? How do we get that t? We don't want x. So then you're going to replace each x with 1/2 t squared. So you simply plug in 1/2 t squared into x, and then you'll get your equation of y of t. So it goes 1/2. Instead of x, I'm going to use 1/2 t squared, because that's what my x is, minus 1/4 ln of 1/2 t squared. Now let's simplify it a little bit. So we get 1/2, 1/4, it's 1/8 t to the 4th minus 1/4 ln 1/2 t squared. Now we have y of t and we have x of t, and we can just find the derivative of each one separately. So derivative of x, and I just want to remind you that x of t was 1/2 t squared. So the derivative would be just t. And derivative of y, and the equation we got, it was t to the 4th over, 1/8 t 4th, 1/8 t to the 4th minus 1/4 ln 1/2 t squared. I hope I'm right. Yes. Okay, so to find the derivative of that, bring down the 4, and you get the 1/2 t cubed minus 1/4. Now derivative of ln is 1 over x. That would be 1 over 1/2 t squared. But times, you use the chain rule, derivative of that. So we get 1/2 t cubed minus, so because we have 1/2 on the bottom here, so 2 moves up, and then like this. So in 2/4 becomes 1/2, and we still have t squared on the bottom, and derivative of this part right here gives us just t. So that means the final derivative would be 1 over 2t here. So I think we're done. So that's that, and that's that. So now the speed, we know in order to find the speed, we have to do x prime squared plus y prime squared. So t is our equation. You're going to square it, but you need to find the value of x prime of, now what t are we looking at? They gave it to you. T equals 1. So 1. Well, if t is 1, then you just get 1. And then, let me just box it. And then y prime, if t is 1, then y prime of 1 would be 1/2 minus 1/2. It looks like it's 0. So to find the speed, we're going to take the square root, square your x prime of 1, which is 1 squared, and square your y prime of 1, which is 0 squared, and you get 1. So that's your final answer. And that's how you find the speed in this case.